Thank you very much, Chaitanya and his team. And good morning once again to everyone. I think this was the point we left a few days back. So now I'm back once again after every work is over. So the last part was oxidation states. So because they want one electron, so they accept one electron or they share one electron. That means what? Minus 1 is common OS. Apart from minus 1, uh, they show plus also. So plus OS will be shown by other members, not by the fluorine. Okay. So uh, fluorine will not show at any cost the plus one because it is branded, it is grounded, it is made as a boss of what all other elements with minus 1. So only with fluorine it is minus 1, otherwise with other members minus 1 and plus others plus OS depend upon how many they want to lose, because one more plus point is the other members, they have D entry, F entry is there. So they can make use of those orbitals, and ultimately they can go for even loss of electron also. Okay, so this type of loss of electron by the halogen usually uncommon, unusual, but still they do. Okay, so halogens will also go for loss of electron. When you see oxo acids or interhalogen compounds, oxides, that time we see plus OS by the halogen because situation is demanding, so what to do? That's why they go for the ultimately once again the same what statement, variety and the complexity is there in the nature. It is because of what all these atoms they go for sharing, losing and gaining. Okay, right. Now today is next. So after this one, I think we will go to this part. Come on, yeah, this part. Yeah, oxidizing power. So the one which loses electron is a reducing agent, and the one which is accepting electron is an oxidizing agent. Redox reaction and the 11th class. Okay, so extreme left side they are the electron donors, so they are the reducing agents, and extreme right side they are the electron acceptor, so they are the oxidizing agents. So because 17th group is the extreme left, excluding 18th we don't consider the reactivity, so they are the best oxidizing agents on the modern periodic table. Okay, and among them fluorine is the best because quickly it accepts the electron. So therefore, the best oxidizing agent is fluorine. Hmm? So the reactions you can see among halogens only. So one is giving, one is taking, all those happens. But with the fluorine, it is only accepting. But you see here, whenever halogens are electron acceptor, agreed. Okay. But after accepting, they want to give back. See, F want to accept to become F minus. Cl want to accept to become Cl minus. Once they become Cl minus, Br minus, then they want to give back if the demand is there by someone. That them they act as what? Reducing agents. Okay. Fluorine is an oxidizing agent. Fluoride is a reducing agent. Okay. So halogens are best oxidizing, but their anions, they are the reducing agents. Okay. Right. So reactions, you kindly go through this part. Okay. So now the blue part is what? The blue part I'll explain. Okay. What is the blue part here? Despite what might be expected, halide particles act as reducing agents. Okay. Because they are electron donors. Fluoride, chloride, bromide, all those are called as halides. Okay. Right. Now reaction with hydrogen. Expected is hydrides. Okay. So fluorine with hydrogen, chlorine with hydrogen, and so on. Corresponding hydrides are formed. So hydride of fluorine, hydride of chlorine. But in general, we say it is a hydrogen fluoride, hydrogen chloride. So that is a common name we say. But in general, they are called what? Hydrides. With oxygen, oxides. Okay, oxides, anions. So especially with oxygen, no, halogens are best friends. Okay, that too, chlorine is the best friend. Chlorine's best friend is hydrogen and oxygen. Hmm. Okay, so they always go together. So this is explained on the reactivity. Okay, right. Friendship is here. Friendship is here on the reactivity. So many chlorides are there, oxo anions, perchlorates. Okay, so variety of chlorine halogen compounds are there, because halogens are most reactive. Extreme left, extreme left most reactive, extreme right most reactive. That means we are on the extreme right, so most reactive side. So we expect a lot of reactivity from this family. See, chloride, chlorate, perchlorate, dichlorine monoxide, chlorine oxide, many are there with special oxygen. So all those we don't learn, just have a glance. Okay. So as an extra glance you can go through. Okay, right. Now reaction with metals. Halogens, definitely this is the best pair. Extreme left, extreme right. Give and take business. Okay. Easy transfer of electron. So ionic bond is expected. So best ionic compounds from extreme left and extreme right. Therefore, they will react with what? Metals. But with left, with fast, with the middle, slowly they react. Okay. But they react. So they react and give what? Metallic halides. And the best metallic halide what we are using already is what? Sodium chloride. Again, as usual, anomalous behavior of fluorine, the first member, the first born baby in a family. Okay, and even reasons are also same because it's a common reason, like a genetic code. So genes they have some properties, properties. So in the same way, so we have certain what reasons, same reasons we have to give for everything, starting from the 13th till 18th. Okay, so the anomalous behavior in properties like IE, okay, BDE, so all those are, it is because of what? Because of small size, high electronegativity, all the same reasons. One main is what? No d orbitals, no d orbitals. Okay, right. Now uses of halogen. Main use of fluorine, so I have taken some samples. So separately, fluorine we know what? Teeth enamel, okay, for the tooth decay. So we require a small amount of halogen. Therefore, fluorides are added in different forms, not in the HF form. So in the metallic fluorides are added to the toothpaste so that they give health, good health to the teeth or gum. So all toothpaste contains small amount of fluorine in the form of fluoride, that too with other combination. And regarding chlorine, the best is what you have seen in the swimming pool or in the aquarium or in the water board. So chlorine is used to treat water. Okay, so it is having a disinfectant property. So therefore, it is used to kill microorganisms which they develop due to some reasons in the water, stagnant, especially the stagnated water. That's why in the swimming pool they keep changing the water due to that using the suction pump. Otherwise, water if it is stagnated, they develop some unwanted things. So chlorine mean is what? Mean is to disinfect. Second is as a chlorinating agent. Chlorine will find many applications, especially in the organic chemistry. And chlorine is utilized as a part of cleansing. This I told already. Bleaching. And iodine also has got some antiseptic and antimicrobial property on the skin part. Okay, skin part. Okay, so therefore iodine is made use in most of the skin ointments along with the sulfur. I told sulfur also. So sulfur plays, iodine plays, all these. So for dressing or for curing or for controlling the bacterial growth on the skin when your wound is there. So all those, for all the purposes which are related to skin, so it is employed. So that means iodine is employed in the especially pharmacy industry. Now today's important topic of discussion, that is today we have to start the important compound of group 17, that is chlorine. And you see the mark is a dangerous mark, skull mark. That means chlorine is highly what dangerous. Okay, it is a poisonous, not only dangerous. It is because directly it chokes our lungs. Therefore, when it chokes the lungs, blocks the lungs for the oxygen, then normally it is poison only. Okay, so what is poison? The one which gives death. So it is highly poisonous. Therefore, who are all working, so they are given special mask. Okay, that is there mask. All those they are given, and even in fact this property I told without the permission of somebody's UNO or some head, it was made use in the war also, but not allowed. But people are there, no, people are there to use. So without permission, they want to win. So by hook or crook. So let us not go for the crook method. So we'll go for our ability. So ultimately, our human beings are very important. Humankind, life is there on the earth. So every human being on earth is very important. So let us take care of all those human beings. Therefore, whenever we are using harmful chemicals, be careful. Now, preparation of chlorine. So it is made by the action of HCl and MnO2. So immediately you will get, because Cl reacts immediately with MnO2. So to give chlorine gas, and that is collected. How it is collected? It is collected by the downward displacement of water, because chlorine is lighter than air. So therefore, upward displacement of air is not followed here, like how we followed in the case of carbon dioxide and the SO2, but here it is a downward displacement of water, depend upon the density, all those property. Okay, right. So whatever required MnO2 HCl are taken in the container using diesel funnel, and it is heated, reaction starts and chlorine comes out. So that chlorine is collected in the gas jar and is studied the properties, and remaining side products are left in the round bottom flask only, and they are purified afterwards. But our main aim is what? Our main aim is to prepare chlorine, and you have prepared it, and now we will go to study this property later. Okay, right. One more way is there. So along with MnO2, now we can go for H2SO4 also, NaCl also combination, so that chlorine will get. So different way of now, or using the KMnO4 HCl combination, Cl2 is made separate. Here it is KMnO4 is OA and HCl is RA. So they undergo redox reaction. Ultimately, major product is what? Chlorine, and others are there. Now this is most important from an exam point. Decon process. Okay, so by English chemist Henry Decon. So he made use of atmospheric air or oxygen in the presence of copper chloride and all those conditions. So equations were given at the bottom. So using that equation, he prepared chlorine gas and collected. So but for this we require a Cl, and SCl was prepared by one more process, that is called LeBlanc process. So LeBlanc process stopped due to some technical problems after some years. So therefore, when the LeBlanc process started stopped, then supply of SCl to this Decon process also, then he has to depend some other industry to supply SCl. So actually LeBlanc and Decon, they are very close. They together started the industry. That's why this process is called as not only Decon. In some books you will find it is Decon LeBlanc process. So because for the chlorine, he is the one who is supplying HCl. So no business no. So due to some reason, I don't know exactly. So it stopped. Now Decon process, we don't use it. We don't use a Decon process at present, because one more process we have, best process, chloralkali method is there. Okay, so there are a variety of methods available nowadays. This is very old. You see the year 1868. Okay, so very old process, but still, if you get a SCl in large amount supply, then you can go for this method. Otherwise, you can go for the modern methods available. So in the industrial chemistry, this is the electrolytic dissociation of sodium chloride, best method. Sodium chloride is available in ocean. Okay, 33%. So please collect it, separate it, purify it, then go for a molten condition, that is liquid condition. Then apply please allow the current to flow. So Na separates, Cl separates. So Na being a plus ion, so it moves towards the cathode, and the Cl being the negative ion, move towards the anode. So because Na is a loss of electron, so therefore Na actually wants electron. That electron is given by the chloride. So first what happens, NaCl separates into Na plus ion and the Cl minus ion. So those two ions will move separately according to the charges. So Cl, because rich in electron, therefore it gives electron, that is moves, you see the diagrammatically is given. Okay. So Cl gives electron, and after giving electron, Cl minus becomes Cl, normal Cl. So either many normal Cl combined become Cl2, that is inside. So but the electrons are taken by the this water sodium, because sodium is in need. So this is what again once again redox reaction, loss of electron and gain of electron. Okay, so the simple and best example for the redox reaction is what? Formation of sodium chloride or decomposition of sodium chloride. So all those, so somewhere loss, somewhere gain, and the chlorine gas formed at anode and is collected. Okay, and the sodium, sorry, chlorine is collected at the anode, and the sodium is collected at the cathode, and this sodium further reacts with the water. So it is a molten condition of NaCl. No? So amount of water is there because sodium is highly reactive. It has got a great affinity for the water. So it reacts with the water and forms sodium hydroxide, and that is also taken back. That means from this method, not only we get chlorine, we also get the sodium hydroxide, that is alkali, which is the main important what ingredient for the soaps and the detergents industry. Okay, along with sodium carbonate. So all those are interrelated. Now properties. First physical, then the physical a little, and main properties are chemical properties, because from the chemical properties we get different products, and if they're useful in our everyday life, we use it. Okay, right. So greenish yellow at room temperature, okay, and normal temperature NTP, density, all those data. Chlorine is soluble in water. So chlorine water, we have heard, no? Chlorine water. Hmm? So chlorine tablets are dissolved in the drinking water, so that water is made safe, potable, again filtration, all that. So there is a water board under the DC control that will do the work, so that safe drinking water is supplied to different parts of your area. Hmm? So its aqueous solution is called chlorine water. So in the form of chlorine water, in the form of chlorine tablet, in the form of chlorine powder, in the form of chlorine gas, in variety of form, the chlorine is used for the disinfection. Okay, right. So which consists of a mixture of chlorine, hydrochloric acid, and hypochlorous acid, SClO. So that means chlorine water, not only it is a chlorine plus water, some other are there. So they also play the important role as a antimicrobial agents. And the boiling point and melting point just have a data. We don't use anywhere here. So data. So only separation. Now the chlorine is reactive with metals as well as with all elements. Most reactive, no? Extreme right. Hmm? So fluorine being a small, we don't anomalous behavior. So chlorine, next is chlorine, the chance. So chlorine reacts with maximum what element that this some examples I brought here. So aluminum I brought, sodium metals and non-metals. So corresponding chlorides are found here. Okay. Now I told chlorine's best friend is hydrogen. Chlorine's best friend is what? Hydrogen, like water. Chlorine water, like chlorine hydrogen. So chlorine hydrogen. So whenever chlorine gets a chance to get hydrogen, easily it accepts. Okay. So first is water, direct combination. Otherwise, in the H2S, H is there. No? H will come with the Cl and S is made free. In the same way, from the hydrocarbon, H is made to react with this one, and the carbon is made free. So chlorine's best friend is hydrogen. So this is proved by chemical reactions. Now chlorine with ammonia, normally we use in the fertilizer industry. This one, okay. So reactants are same, but if you take ammonia in excess, you will get ammonium chloride, and if you take the chlorine excess, you will get the NCl3. It is nitrogen trichloride. So if ammonia is excess, ammonium chloride is formed, that is sent to the fertilizer industry. If ammonia is in excess, sorry, ammonia excess, fertilizer, chlorine excess, that time NCl3 little slightly dangerous. So wherever pest control is there, so for all that it is sent. Okay, but it is related to the agriculture or the horticulture area. So chlorine and ammonia reacts. Only thing is which one is excess, that matters, that they will control. So there are chemist people working. So under the controlled reaction conditions, they get the desired product. They will design. They are called the designer. How we design clothes, the fashion designer. So they are the fashion designers. So they are called the chemical designers. So variety of designers are available in the in our life. So they design, and accordingly the route is planned, and products are planned. So ultimately we get NCl3 or NH4Cl, and both are useful for the chemical industry. This is again one more most likely questions, or the most likely reaction for the knowledge as well as examination. This is regarding the bleaching powder. Okay. So how bleaching powder is prepared? So bleach means to remove color or something. So chlorine when reacts with sodium hydroxide to give NaCl, NaClO, okay, and H2O. So this combination is called what? Bleaching action. Hmm? So it is because of what? ClO minus. NaClO is there in that Na plus sign and ClO is minus ion. So that ClO minus ion will play the role in bleaching action of the water. Chlorine. So it is chlorine converting into in that form it will act. So they will perform the role in different what in a picture. Here we have two reactions. So conditions are different. So if it is cold and the dilute in nature, you see the reaction. Very strong, hot, okay, strong NaOH, strong alkali, which has got a burning sensation. That time we will get NaCl and NaClO3, chloride and H2O. So all those are there. So let us have a look and be careful while writing the equation with the cold and dilute and with hot and the concentrated. This has occurred nearly many 10 times. Okay, so this you pay attention and practice. Now chlorine also reacts with the CaOH twice and gives a calcium oxychloride, which is called as the bleaching powder. There it has a bleaching action. Here is a bleaching powder. Okay, so bleaching powder, we say in the 10th class we learnt some important compounds of calcium. So there we wrote what the last one, which are written at the bottom, CaOH twice plus Cl2. That gives you CaOCl2 plus water, calcium oxychloride, commonly called as what? Popularly called as a bleaching powder. But actual composition, this is also correct. What is bleaching powder? It is calcium oxychloride. Agreed. But if you want in the 11th and 12th, the correct way of writing bleaching powder is what? Bleaching powder is, it is the mixture form. It is actually CaOCl twice, CaCl2, CaOH twice. Okay. So this form, this red part. So this is the actual composition, but we take it as calcium oxychloride. So both are allowed. Both are allowed. So if you write this one, it is beautiful. Okay. Now you please see this one. Many reactions here. Okay. So if you look at all these reactions, so what comes to our mind? So that means chlorine reacts with hydrocarbons. Okay. Whether it is saturated, unsaturated. Okay. In the unsaturated, whether it is aliphatic or aromatic. So chlorine, I am ready to react. Most reactive. Therefore, chlorine is used, I told you, it is used as a chlorinating agent directly. So we have seen the substitution reactions of the alkanes where chlorine is made to react with the methane. One example you have seen. Okay. So more the number of carbon, more the number of products. Again, separation becomes again difficulty. So all those we learnt in the 11th class. In the same way, chlorine also reacts with water, whether it is a double or triple bond, it will add. So there, question of what you go I come is not there directly because they want. So pi electrons are highly unstable. So therefore, you can easily add electrons on the double bond or the triple bond. Accordingly, double bond becomes a single bond, and if it is a triple bond, and triple bond is becoming the double, double to triple. So all these will happen. So that means what? That means chlorine's best use is in the organic chemistry. So you will see many, whether it is a Grignard reagent, aldehydes, ketones. So in almost all area of organic chemistry, chlorine role is there. So chlorine as an explosive, chlorine as a dyes, so in different products, in different ratio, in different proportion, it plays an important role. So that's why 4 separate reactions I brought here. So one with alkane, so addition reactions, that is only I wrote in detail with methane. Just to recall 11th class first chapter organic chemistry knowledge. And the second is what with alkene, taking example as ethene. So ethene with chlorine, dichloroethane. Okay, this also we learnt. So in the IPAC nomenclature we learnt, and in the preparation part also we learnt last year alkane, alkene, alkyne, and the arene. So with alkyne, so first double bond, then triple bond, single bond. So accordingly 1,1,2,2 tetrachloroethane or 1,2 dichloroethane if it is only 1 mole. So all those we learnt. Once is small. So this is a kind of a recap slide. Hmm? Now you see with the benzene, not only with alkene and the alkyne, with the arenes also. So with the equation I wrote, using the nucleus also I wrote. So benzene nucleus with chlorine, chlorobenzene. So chlorine finds many applications in the especially organic chemistry. This is just sample. Even chlorine reacts with what? Alkadynes. So alkadynes are there, alkatrines are there. So dienes means what? Diene, two ene, triene, three ene, tetraene, many. So you know very well organic chemistry is Brahmanda. So everywhere chlorine role is to add, just add. Okay. If you are adding me, okay, I'm ready. Substituting me, I'm ready. So on the ring, okay. So when you are, you want to break the ring and make it completely all six chlorine are formed. So benzene hexachloride BSC is a fertilizer. So I am ready as a chlorobenzene or as a benzene hexachloride, depend upon conditions only. So under what condition you are making me to add, that matters a lot. So chlorine is most user friendly or uh, industrial friendly chemical. Only thing is it is a poisonous. That part you have to keep in the mind. So using gloves and masks and the aprons, say you can handle chlorine. Nowadays we find many chlorine polymers, So polyvinyl chloride. See, tons of PVC pipes are there everywhere, whether it is for agriculture purpose or for electrical purpose. So every day we see lots of PVC pipes are sold in the market. So PVC business is in the crores. Okay. So the one in the beginning who has started the business of what uh, this PVC pipes, he is earning like anything. Hmm? So that all is there. So I think my WebEx is giving me indication that. So I am going to wind up this session. So tomorrow we are going to wind up this 17th group Saturday weekend, and afterwards Monday or Tuesday. Monday I am keeping blank. So Tuesday till Saturday at any cost or before that we have to go for the winding of 18th group, so that by this month end both will be completed and with fresh mood, 2 chapters, 2 weeks. Okay. So with this, before it winds, I am only winding the session very easy. So preparation properties and uses we discuss next session of chlorine. And before chlorine, some general trends and general information regarding the group 17th. So with this, let us wind up. So thank you for being with me, Vivek and Chaitanya Vaishnav team. So remaining part in the days to come. Thank you very much, my dear students.
Thank you, sir.
Thank you. Thank you very much.
Thank you, sir.
Thank you.
Thank you,